Unit 4, Electromagnetic Waves. Now, what are electromagnetic waves? Whenever there is an electric and a magnetic disturbance in space at right angles to each other, then there is a wave generated perpendicular to both, and that is an electromagnetic wave. Now, the definition you have here: an electromagnetic wave is a wave of oscillations of electric and magnetic fields in mutually perpendicular planes. And these oscillations are perpendicular to the direction of propagation of the wave. Now, if the electric and magnetic fields of a wave lie in a plane perpendicular to the direction of the wave they travel, the wave is called as plane wave. Now, we have already learnt Maxwell's equations in the earlier chapter. We have to solve these Maxwell's equations to describe EM wave motion. The EM wave can travel either in free space or perfect dielectrics or lossy dielectrics or good conductors. In free space, sigma is 0, epsilon is equal to epsilon naught, mu is equal to mu naught. Now, wave equations in free space. In a homogeneous medium, there are no charges, no conduction current, and therefore J is 0. For free space, epsilon is equal to epsilon naught, mu is equal to mu naught. Epsilon naught is permeability of free space. Mu naught permittivity of free space. Both mean ability of the lines of force to pass through the medium. The Maxwell's equations in free space are the four equations. Del cross E is minus dou B by dou T. This can be written as mu 0 outside dou H by dou T. This is the first equation of Maxwell in free space. Second one, del cross H, dou D by dou T. In place of D, write epsilon E. You'll get epsilon naught dou E by dou T. Third equation, del dot D equal to 0. Or del dot E equal to 0. Fourth equation, del dot B equal to 0 and del dot H equal to 0. These are the four equations of Maxwell in free space. Now we will derive an electromagnetic wave equation in terms of E. Consider the first Maxwell equation. Del cross E is minus mu 0 dou H by dou T. Take the curl on both sides, that is, in front of this del cross, in front of this del cross. That is called taking curl. So we have del cross E is equal to minus mu 0 del cross dou H by dou T. Now this Dou by dou t can be removed outside. Del cross is written inside in the next step. This is equation 5. Now del cross E is a vector identity which is equal to this. Del cross del dot E minus del square E. This is a formula identity. Del dot E is 0. From where we have here. So substituting this 0. We have del cross E is minus del square E. This is equation 6. Now if you look at 5 and 6, left hand sides are equal. Equate right hand sides. You'll get this. Minus del square E equal to minus mu 0 dou by dou t of del cross H. Both sides minus will get cancelled, but before that you can substitute in place of H epsilon naught E in place of H. Okay, we have epsilon naught E. So we have here epsilon naught dou E by dou t, or dou by dou t becomes dou square by dou t square. So minus mu 0 epsilon 0 dou square E by dou t square. So both sides minus sign, now you can cancel. You have this expression. Del square E is mu 0 epsilon naught dou square E by dou t square. This is the wave equation for propagation of electric field in free space. Now this same expression can be expressed in the three coordinates as dou square Ex by dou x square, y square, z square, this. That is, you're splitting that equation into the three axes x, y and z. This is a wave equation in terms of E. Same wave equation we can have in terms of B. The wave equation in terms of H is del square H is mu 0 epsilon naught dou square H by dou t square. In place of H, substitute B by mu 0. Del square B by mu 0 is equal to mu 0 epsilon naught dou square by dou t square B by mu 0. Mu 0 will cancel. You are left with this. That is del square B equal to mu 0 epsilon naught dou square B by dou t square. This is wave equation in terms of B. In terms of E, there was E here. In terms of B, there is B here. Now the standard form of this wave equation. You can write this as del square A equal to mu 0 epsilon naught dou square A by dou t square. In place of A, either E or B can be written, electric field or magnetic field. Now mu 0 epsilon naught can be written as 1 by V square, where V square is 1 by mu naught epsilon naught. Or V is equal to 1 by root mu naught epsilon naught. Mu 0 is permeability of free space, farads per meter. Epsilon naught, permittivity of free space. This is a value. So for problems, this is important. These are standard values which you should remember. This is a standard form of wave equation. In place of A, you can have electric field intensity or magnetic field intensity, E or P.